Students, in this video we are going to discuss relations. Relations is the common word we are using in day-to-day life. We used to say he is my relative, am I right? Or he is my relation. Very clear. So like that, in mathematics also we are used to use relations. Normal life also we used to say that. For example, Chennai is the capital of Tamil Nadu. So here we are using the word capital. New Delhi is the capital of India. It's given there. That you can see there. New Delhi is related with India. That we can denote by order pair. New Delhi, India. Here the relation is the capital of. Like that, in geometry, line AB is perpendicular to line XY. That we are relating line AB and line XY. So we can write line AB or is related with line XY. In order pair, we can denote by line AB, line XY. Now we are saying that the third one, -1 is greater than -5. Here the relation is greater than. So -1 related with -5. Here the relation is greater than. Order pair is -1, -5. That you can't change it as -5, -1. That you have to write in the same form. Next one, L is a line of symmetry for triangle PQR. Line is related with triangular PQR. Here the relation is a line of symmetry for. Order pair is L, triangle PQR. Now we can see the definition of relation. Let A and B be any two non-empty sets. It should be non-empty. A relation or from A to B. A relation or from A to B is a subset of A cross B. That we learned in the previous video. We studied. We have doubt in cross product or Cartesian product, you can watch the previous video. A relation or from A to B is a subset of A cross B satisfying some specified conditions. Let X belongs to A is related to Y belongs to B through R. Then we write it as X is related to Y, that is X or Y. X or Y if and only if order pair X, Y belongs to capital R. Here the domain is always the first set. Here the first one is in X, Y. X belongs to A. A is the first set. So domain of the relation R is equal to set X belongs to A such that X is related to Y for some Y belongs to B. Codomain. Codomain is always the second set, B set. Then the range of the relation R is equal to, in the order pair X, Y, the second element, set Y belongs to B such that X is related to Y for some X belongs to A. So while doing the sum, you will get a clear idea about domain, codomain and range. Domain will be always the subset of the first set, that is A. range will be the subset of the second set of codomain B. Next is null relation. Let us consider the following example. Suppose A is equal to minus 3, minus 2, minus 1 and B is equal to 1, 2, 3, 4. A relation from A to B is defined as A minus B is equal to 8. It's very clear that A is from A set and B is from B set. You have to subtract it. It should be equal to 8. You take any choice from that. No pair will satisfy that condition. Alright. Therefore, we can say that there is no element in R. So that R is equal to null set. R is null set. Clear, children? R is null set. A relation which contains no element is called a null relation. So you have to learn the definition of null relation. A relation which contains no element is called a null relation. If n is equal to p, that is number of elements in A set is p and n of b is q, then the total number of relations that exist from A to B is 2 power p into q. So based on this, they can ask even objective. They may give number of elements in A is 2, number of elements in B is 5. Then the total number of relations they can ask. Then 2 power 2 into 5. That is 2 power 10. You know the value of 2 power 10 is 1024. Clear, children? So like that they can ask objectives. Listen. Let A is equal to 2, 3, 5, 7 and B is equal to 4, 8, 12. Clear, children? You know how to write A cross B. Already we studied. A cross B. We can write. First element will be 2, 4. Then will be 3, 8 and so on. The last element will be 7, 12 in order. Okay, children? Right. Whatever may be. Now I am defining a relation is less than. Here yes is less than is the relation or. Okay, children. So from A cross B we have to write all the order pairs which satisfies this condition. Therefore R is equal to, R is a set now. Here it's a relation which is given. 2 is less than 4 is true. So I can write 2, 4. 3 is less than 4. 5 is not less than 4. I can't go for that. Next I am taking 2, 8 since 2 is less than 8. Next 3, 8. 5, 8. 7, 8. Clear, students? Then you can write the next element. 2 is less than 12. So 2, 12. 3, 12. 5, 12. Then last number or last order pair is 7 is less than 12. So we can write 7, 12. Here it's very clear that I can write the domain. We have to take from R the first entries 2, 3, 2, 3. Then you just move like that. You have 5, then 7. That's all the numbers. Am I right? Then if they are asking codomain, codomain is equal to B set always. Right, children? Next, range. Range is equal to, you can take the second elements in each order pair. That is 4, 8, 12. In this case, range is equal to codomain, not always. Okay, children? Like that, here domain is equal to A. We won't get always like that. Right, children? So, depends upon the relation we used to have that. Suppose I am taking another relation. R1 is equal to. Is equal to is the relation I am assuming here. For the same sets A and B. Here no number is equal to the next number from A to B. 2 is not equal to 4. I can't take 2, 4. So like that you can check. I am getting null set. So R1 is known as, therefore R1 is null relation. Now exercise 1.2. First question. Let A is equal to set 1, 2, 3, 7 and B is equal to set 3, 0, minus 1, 7. Which of the following are relations from A to B? Here I am considering the first question. Here it's given R1 is equal to 2, 1, 7, 1. Here 1 is not from B. The second entries must be from the second set. Therefore, here 1 is not in B. Therefore, R1 is not a relation. Okay, students. Now I am going for R2. Second one. R2 is equal to minus 1, 1. Once again, you can go with the same reason, or even the first entry minus 1. It's not from A. Here, minus 1 is not an element of A. Therefore, R2 is not a relation. Third one, R3, 2, minus 1, 7, 7, 1, 3. First you can check the first entries. 2, 7, 1. All these elements are from the first set A. Next is minus 1, 7, 3. All those elements are from B. Here 2, 7, 1 belongs to A and minus 1, 7, 3 belongs to B. Therefore, R3 is a relation. From A to B. Fourth subdivision. R4 is equal to 7, minus 1, 0, 3, 3, 3, 0, 7. Okay, children. Now you check with the first entries. 7, it's okay, it's from A. But 0, it's not from A. Since 0 is not an element of A, therefore R4 is not a relation. Now the second question, that A is equal to 1, 2, 3, etc. 45 and R be the relation defined as is square of a number on A. Write R as a subset of A cross A. Also find the domain and range of R. Given A is equal to 1, 2, 3, 4, etc. 45. Dear children. And R is the relation. And R is the relation is given is square of a number. Dear children. Now I can write 1 square is equal to 1. 2 square is equal to 4. 3 square is equal to 9. 4 square is equal to 16. 5 square is equal to 25. 6 square is equal to 36. If you are going for 7 square, it's 49. It's not from A set. So you can stop with this. Now I am going to take 9 is the square of a number 3. Clear, children? Therefore, R is equal to, like this you have to write. What is the meaning of this? This we can written as 9, 3. So first one I can write it as 1, 1. Next is 4, 2. Next is 9, 3. 16, 4. 25, 5. 36, 6. Clear, children? So 9 is the square of a number 3. So we can write only 9, 3, not 3, 9. Since 3 is not the square of a number 9. So which means 9 square. Okay, children? So 9 is the square of a number 3. Now we can write the required things. So this is the subset of A cross A. Okay, children. Also find the domain. Domain is equal to the first entries 1, 4, 9, 16, 25, 36. Now the range is equal to 1, 2, 3, 4, 5, 6. Very clear, children? This is domain and range. Third question, a relation R is given by the set x comma y such that y is equal to x plus 3. X belongs to set 0, 1, 2, 3, 4, 5. Solution. So given y is equal to x plus 3 and x belongs to 0, 1, 2, 3, 4, 5. Clear, children? Now put x equal to 0, y is equal to 3 we are getting. When x equal to 1, y is equal to 4. When x equal to 2, y is equal to 5. When x equal to 3, we are getting y is equal to 3 plus 3, 6. When x equal to 4, y is equal to 4 plus 3, 7. When x equal to 5, now y is equal to 5 plus 3 is 8. Now I can write OR set, that is the relation set. 0, 3, 1, 4, 2, 5, 3, 6, 4, 7, 5, 8. Therefore, domain is equal to, the first entry is 0, 1, 2, 3, 4 and 5. Then we need range. Range is equal to, we are getting 3, 4, 5, 6, 7 and 8. Fourth question, represent each of the given relations by, first one, an arrow diagram, a graph and a set in roster form. Solution, first one, given x is equal to 2y, x belongs to 2, 3, 4, 5 and y belongs to 1, 2, 3, 4. Now, we have to substitute the values in the respective places. When y is equal to 1, I am substituting. What I am getting, x is equal to 2. It's from that set, no problem. Next, when y is equal to 2, x is equal to 2, 2s are 4. It's also there. Suppose you are taking 3, 2 3s are 6. It's not possible. Am I right? Even 4 also, if you are taking 4 also, it's not possible. Therefore, we can write the relation as r is equal to 2, 1 and 4, 2. While writing the relation, you have to be careful. Normally, suddenly if you are looking there, we used to take 1, 2. But y is equal to 1 and x is equal to 2. It should be in the order x, y. It's given in the problem. Now we have to draw the arrow diagram, then graph, set in roster form. That is the C. C is this actually. This is roster form. Am I right? The relation. Now we can go for arrow diagram. Now we can draw the arrow diagram. The first set, the elements are 2, 3, 4, 5. In Y set, the elements are 1, 2, 3, 4. Now 2 is related with 1, so I can draw a line, arrow diagram. Then 4 is related with 2, so draw a line straight to 2. There, children. Then for graph, I consider x-axis and y-axis. Let it be origin. So we are assuming that x-axis, the numbers are 1, 2, 3, 4, 5. Here I am taking, it's 1, 2, 3, 4. Now the order pairs are 2, 1. 2, 1. Okay, children. Next is 4, 2. Approximately I am taking here. It's 4, 2. This is the graph and the previous one is the arrow diagram. Here one more part is there. There it's given y is equal to x plus 3. Second subdivision. X comma y are natural numbers less than 10. So you can take y is equal to x plus 3 like this problem. And x belongs to 1, 2, 3 up to 9. Y also belongs to like that. Then you have to check like this and you have to write in roster form, arrow diagram and graph. Fifth question, a company has 4 categories of employees given by assistants denoted by A, clerk C, managers M, executive C. Just you go through the content and keep it in your mind. Only after that we are going to start the work. The company provides 10,000, 25,000, 50,000, 1 lakh as salaries to the people who work in the categories A, C, M, E. Okay, assistant, clerk, managers, executives. 10,000, 25,000, 50,000, 1 lakh. In assistant, 5 assistants are there. Clerk, 4 clerk are there. Then managers 3, executives 2. Okay, children. And if the relation R is defined by X related to Y, X is the salary. X is the salary to person Y. Okay, children. Express the relation R through an order pair and an arrow diagram. For that, you have to consider order pair you have to write. Then you have to go for arrow diagram. First, we can write the solution. From the data, we can write the order pair of the relation. So, relation is equal to what you can write. First one is salary. 10,000, A1. 10,000, A2. 10,000, A3. 10,000, A3, A4. 10,000, A5. 5 assistants. Now you can go for clerks. Their salaries are 25,000. 25,000, C1. 25,000, C2. 25,000, C3. 25,000, C4. So 4 clerks. Now managers. That is 50,000 their salaries. 50,000, M1. 50,000, M2. 50,000, M3. Now we have to move on to executives. Executives, you know, their salaries are 1 lakh. So E1, 1 lakh. E2, second executive. So this is the order pair, set of order pairs, that is the relation. Okay, children. Now we have to go for arrow diagram. For arrow diagram, I consider 2 sets. The first set is, you know that it's salaries. I am using S for that notation. This is workers. Here first salary is 10,000. Next is 25,000. Next is 50,000 for managers. Next is 1 lakh for executives. Now 5 assistants A1, A2, A3, A4, A5. So I can join A1, 10,000 to A1, A2, A3, A4, A5 like this. Then clerk 1, 2, 3, 4. This also you have to join with arrows. Okay, children. Next is managers M1, M2, M3. 50,000 salary. So 50,000 comma M1, M2, M3. 1 lakh salary for 2 executives E1, E2. So 10,000. So with scale you have to draw the arrows neatly. Clear, children? This is the required arrow diagram. I hope you will be thorough with the concept of relation, arrow diagram, graph, then order pair. Okay, children, you just make it thorough with the definitions and please practice the example sums. All the best. May God bless you.